Measurement of matter. Exercises. Q1. Give examples. A positive radicals, B basic radicals, C composite radicals, D metals with variable valency, E bivalent acidic radicals, F trivalent basic radicals. Answer. A positive radicals. Positively charged ions are called cations. Examples. NH4+, K+, Fe+2, Al+3. B basic radicals. The cationic radicals are called basic radicals. Basic radicals are formed by removal of electrons from the atoms of metals. Example. Na+, Cu2+, Ag+, Mg+2, O+3. C composite radicals. When a radical is a group of atoms carrying a charge, it is called composite radical. Examples. NO3, ClO3, SO42, NH4+, MnO4. D metals with variable valency. Under different conditions, the atoms of some elements give away or take up different numbers of electrons. In such cases, those elements exhibit more than one valency. This property of elements is called variable valency. Examples. Iron Fe exhibits the variable valencies 2 and 3, Fe2+ and Fe3+. Gold O exhibits the variable valencies 1 and 3, O+ and O3+. Copper Cu exhibits the variable valencies 1 and 2, Cu+ and Cu2+. Mercury Hg exhibits the variable valencies 1 and 2, Hg+ and Hg2+. E bivalent acidic radicals. Bivalent refers to an element whose atom can replace two atoms of hydrogen or another univalent element. It also refers to a radical that has the same valence as a bivalent atom. Examples. SO42, CO32, C2O42. F trivalent basic radicals. A trivalent basic radical is a cation that has a valency of 3. Examples of trivalence basic radicals are Al3+, Cr3+, Bi3+, and Fe+2. Q2. Write symbols of the following elements and the radicals obtained from them, and indicate the charge on the radicals. Mercury, potassium, nitrogen, copper, sulfur, carbon, chlorine, oxygen. Answer. Q3. Write the steps in deducing the chemical formulae of the following compounds. Sodium sulfate. Answer. Sodium sulfate. Formula. Na2SO4. Steps to obtain the chemical formula. Step 1. To write the symbols of the radicals. Basic radical on the left. NaSO4. Step 2. To write the valency below the respective radical. NaSO4. 1, 2. Step 3. To cross-multiply as shown by the arrows the number of the radicals. Step 4. To write down the chemical formula of the compound. Na2SO4. Q3. B. Write the steps in deducing the chemical formulae of the following compounds. Potassium nitrate. Answer. Potassium nitrate. Formula. KNO3. Step 1. To write the symbols of the radicals. Basic radical on the left. KNO3. Step 2. To write the valency below the respective radical. KNO3. 1, 1. Step 3. To cross-multiply as shown by the arrows the number of the radicals. Step 4. To write down the chemical formula of the compound. KNO3. Q3. C. Write the steps in deducing the chemical formulae of the following compounds. Ferric phosphate. Answer. Ferric phosphate. Formula. FePO4. Step 1. To write the symbols of the radicals. Basic radical on the left. FePO4. Step 2. To write the valency below the respective radical. FePO4. 3, 3. Step 3. To cross-multiply as shown by the arrows the number of the radicals. FePO4. 3, 3. Step 4. To write down the chemical formula of the compound. FePO4. Q3. D. Write the steps in deducing the chemical formulae of the following compounds. Calcium oxide. Answer. Calcium oxide. Formula. SAO. Step 1. To write the symbols of the radicals. Basic radical on the left. CaO. Step 2. To write the valency below the respective radical. CaO plus 2 to 2. Step 3. To cross-multiply as shown by the arrows the number of the radicals. CaO plus 2 to 2. Step 4. To write down the chemical formula of the compound in the simplest form. SAO formula of the compound. AlO3. Q3. Write the steps in deducing the chemical formulae of the following compounds. Aluminium hydroxide. Answer. Aluminum hydroxide. Formula. AlO3. Step 1. To write the symbols of the radicals. Basic radical on the left. AlO. Step 2. To write the valency below the respective radical. AlO3-1. Step 3. To cross-multiply as shown by the arrows the number of the radicals. Step 4. To write down the chemical formula of the compound. AlO3. Q4. Write answers to the following questions and explain your answers. Explain how the element sodium is monovalent. Answer. The atomic number of sodium is 11. Sodium has 1 electron in its outermost shell, and to acquire noble gas configuration it will lose 1 electron or it needs to gain 7 electrons. However, the former is possible. Hence it will lose 1 electron, and so the element sodium is monovalent. Q4b. Write answers to the following questions and explain your answers. M is a bivalent metal. Write down the steps to find the chemical formulae of its compounds formed with the radicals, sulfate and phosphate. Answer. M is bivalent, which means it has a valency of 2. I for sulfate. Step 1. To write the symbols of the radicals. Basic radical on the left. MsO4. Step 2. To write the valency below the respective radical. MsO4 plus 2 to 2. Step 3. To cross-multiply as shown by the arrows the number of the radicals. Step 4. To write down the chemical formula of the compound in the simplest form. MsO4. E for phosphate. Step 1. To write the symbols of the radicals. Basic radical on the left. MpO4. Step 2. To write the valency below the respective radical. MpO4 plus 2 to 3. Step 3. To cross-multiply as shown by the arrows the number of the radicals. Step 4. To write down the chemical formula of the compound in the simplest form. M3PO42. Q4. C. Write answers to the following questions and explain your answers. Explain the need for a reference atom for atomic mass. Give some information about 2 reference atoms. Answer. It was not possible for scientists of the 19th century to measure atomic mass accurately. Therefore, the concept of relative mass of an atom was put forth. A reference atom was required for expressing the relative mass of an atom. The hydrogen atom as the lightest was initially chosen as the reference atom. The relative mass of a hydrogen atom which has only 1 proton in its nucleus was accepted as 1,1. Therefore, the magnitude of the relative atomic masses of various atoms became equal to their atomic mass number p plus n. In the course of time, different atoms were chosen as reference atoms. Finally, in 1961, the carbon atom was selected as the reference atom. In this scale, the relative mass of carbon atom was accepted as 12. The relative atomic mass of one hydrogen atom compared to the carbon atom becomes 12 by 1/12, that is 1. The mass of one proton and of one neutron on the scale of relative atomic masses is approximately 1. Q4D. Write answers to the following questions and explain your answers. What is meant by unified atomic mass? Answer. The unified atomic mass unit or Dalton is a standard unit of mass that quantifies mass on an atomic or molecular scale. One unified atomic mass unit is approximately the mass of one nucleon and is numerically equivalent to 1 gram per mole. Q4. Write answers to the following questions and explain your answers. Explain with examples what is meant by a mole of a substance. Answer. 1 mole of a compound is the mass of that substance in grams, equal in magnitude to its molecular mass. The SI unit is mole. Number of moles of a substance N equals mass of substance in grams, molecular mass of substance. The molecular mass of oxygen is 32 U, and therefore 32 grams oxygen is 1 mole of oxygen. The molecular mass of water is 18 U. Therefore, 18 grams of water make 1 mole of water. Q5. Write the names of the following compounds and deduce their molecular masses. Na2SO4, K2CO3, CO2, NaOH, MgCl2, Alco4, NaHCO3. Answer. I. Na2SO4. Sodium sulfate. Steps for finding the molecular mass. Molecular mass of Na2SO4 equals 2, atomic mass of Na plus 1, atomic mass of S plus 4, atomic mass of O, rightwards double arrow molecular mass equals 2, 23 plus 1, 32 plus 4, 16, equals 46 plus 32 plus 64 equals 142 grams per mole E. K2CO3, potassium carbonate. Steps for finding the molecular mass. Molecular mass of K2 Colorado 3 equals 2 times, atomic mass of K plus 1 times, atomic mass of C plus 3 times, atomic mass of O. Molecular mass equals 2 times 39 plus 1 times 12 plus 3 times 16 equals 78 plus 12 plus 48 equals 138 grams per mole E. CO2. Carbon dioxide. Molecular mass of CO2 equals 1 times, atomic mass of C plus 2 times, atomic mass of O. Molecular mass equals 1 times 12 plus 2 times 16 equals 12 plus 32 equals 44 grams per mole IV. NaOH. Sodium hydroxide. Molecular mass of NaOH equals 1 times, atomic mass of Na plus 1 times, atomic mass of O plus 1 times, atomic mass of H. Molecular mass equals 1 times 23 plus 1 times 16 plus 1 times 1 equals 23 plus 16 plus 1 equals 40 grams per mole V. MgCl2. Magnesium chloride. Molecular mass of MgCl2 equals 1 times, atomic mass of Mg plus 2 times, atomic mass of Cl. Molecular mass equals 1 times 24 plus 2 times 35.5 equals 24 plus 70 equals 94 grams per mole V. Alco4. Aluminium phosphate. Molecular mass of Alco4 equals 1 times, atomic mass of Al plus 1 times, atomic mass of P plus 4 times, atomic mass of O. Molecular mass equals 1 times 27 plus 1 times 31 plus 4 times 16 equals 27 plus 31 plus 64 equals 122 grams per mole V. NaHCO3. Sodium bicarbonate. Molecular mass of NaHCO3 equals 1 times, atomic mass of Na plus 1 times, atomic mass of H plus 1 times, atomic mass of C plus 3 times, atomic mass of O. Molecular mass equals 1 times 23 plus 1 times 1 plus 1 times 12 plus 3 times 16 equals 23 plus 1 plus 12 plus 48 equals 84 grams per mole. Q6. 2 samples, M and N, of slaked lime were obtained from 2 different reactions. The details about their composition are as follows. Sample M. Mass. 7 grams mass of constituent oxygen, 2 grams mass of constituent calcium, 5 grams, sample and mass, 1.4 grams mass of constituent oxygen, 0.4 grams mass of constituent calcium, 1.0 grams. Which law of chemical combination does this prove? Explain. Answer. Slaked lime equals calcium hydroxide, CaO2. The law of constant proportion states that the proportion by weight of the constituent elements in the various samples of a compound is fixed. The proportion by weight of oxygen and calcium in slaked lime, in sample M, is 2:5, i.e. 0.4. 1. The proportion by weight of oxygen and calcium in slaked lime, in sample N, is 0.4. 1.0. Since the proportions of constituent elements remain fixed, it follows the law of constant proportion. Q7. Deduce the number of molecules of the following compounds in the given quantities. 32 grams oxygen, 90 grams water, 8.8 grams carbon dioxide, 7.1 grams chlorine. Answer. A. 32 grams of oxygen. Moles equals mass of substance in grams. Molecular mass. Molecular mass of oxygen equals 16. Mass of a substance equals 32 grams. Moles. N equals 32/16 equals 2. N equals 2 mole. 2 moles of oxygen contains 6.022 x 1023 molecules. 2 moles oxygen contains 2x 6.022 x 1023 molecules equals 12.046 x 1023 molecules. B. 90 grams water. Moles equals mass of substance in grams. Molecular mass. Molecular mass of water equals 18. Mass of a substance equals 90 grams. Moles. N equals 90/18 equals 5. N equals 5 moles. 5 moles of oxygen contains 6.022 x 1023 molecules. 5 moles oxygen contains 5x 6.022 x 1023 molecules equals 30.115 times 1023 molecules. C. 8.8 grams carbon dioxide. Moles equals mass of substance in grams. Molecular mass. Molecular mass of CO2 equals 44. Mass of a substance equals 8.8 grams. Moles. N equals 8.8. 44 equals 0.2. N equals 0.2 moles. 0.2 moles of oxygen contains 6.022 x 1023 molecules. 0.2 moles oxygen contains 0.2 x 6.022 x 1023 molecules equals 1.2046 x 1023 molecules. D. 7.1 grams chlorine. Moles equals mass of substance in grams. Molecular mass. Molecular mass of chlorine equals 35.5. Mass of a substance equals 7.1 grams. Moles. N equals 7.1. 35.5 equals 0.2. N equals 0.2 moles. 0.2 moles of oxygen contains 6.022 x 1023 molecules. 0.2 moles oxygen contains 0.2 x 6.022 x 1023 molecules equals 1.2046 x 1023 molecules. Q8. If 0.2 moles of the following substances are required, how many grams of those substances should be taken? Sodium chloride, magnesium oxide, calcium carbonate. Answer. A. Sodium chloride. Moles equals mass of substance in grams. Molecular mass in gram per mole. Molecular mass of NaCl equals 1 times atomic mass of Na plus 1 times atomic mass of Cl equals 1 times 23 plus 1 times 35.5 equals 55.5. Mole equals 0.2 moles given 0.2 equals given mass 55.5. Given mass equals 0.2 times 55.5 equals 11.1 grams. B. Magnesium oxide. Moles equals mass of substance in grams. Molecular mass in gram per mole. Molecular mass of MgO equals 1 times atomic mass of Mg plus 1 times atomic mass of O equals 1 times 24 plus 1 times 16 equals 40. Mole equals 0.2 moles given 0.2 equals given mass 40. Given mass equals 0.2 times 40 equals 8 grams. C. Calcium carbonate. Moles equals mass of substance in grams. Molecular mass in gram per mole. Molecular mass of CaCO3 equals 1 times atomic mass of Ca plus 1 times atomic mass of C plus 3 times atomic mass of O equals 1 times 40 plus 1 times 12 plus 3 times 16 equals 100. Mole equals 0.2 moles given 0.2 equals given mass 100. Given mass equals 0.2 times 100 equals 20 grams.